Okay, we're talking about the basic structure of C++ programming in our C++ Fundamentals video series. And since we're in basic structure, we need to talk about some things dealing with linkage and linkage of names. Now, when we say a name, that's an object, a reference, a function, a type, a template, and a namespace. All of those are considered to be names. And linkage of names is where are those names visible? How are they visible to each other and through various translation units? Remember that a C program, and especially a C++ program, can be made up of multiple translation units. And a translation unit is a file, basically a file of source code. And so what we're looking at is how different translation units see the objects that are within themselves and within other translation units, how they're linked together when you have a whole bunch of translation units and you combine them together to be one large program. There's three kinds of linkages. There's external linkage, internal linkage, and none or no linkage. All right, let's go through and look at those. External linkage means that the items or the item that we are discussing that has external linkage will be visible by all of the translation units in the entire program. A name, remember that was one of many different things. A name that has internal linkage will be visible only within its own translation unit. It will only be visible to the other names and the other items that are within its source file. And then no linkage, that's all your local variables and classes that have been defined without external linkage. That's everything else. And there is no linkage to them. Okay, let's go on. Now here's an example. Here's a linkage of names with external linkage. There you see we have an integer n, which is a global, non-static. It's given external linkage. So since it is defined this is the whole file right here. Since this integer n is defined outside of any class or other function or namespace or anything like that, it is visible by everybody and can be used by everybody and is incredibly dangerous because we don't want to have these kinds of global non-statics floating around in the world out there as giving external linkage. That's really old procedural programming and we don't like to do that anymore. You need to encapsulate data like this inside classes like this down in here. Here we have a member function of this class, and so it will be visible by using C::F to get to it, but it will have external linkage. So anything else in another translation unit could reference this function by using C::F, the fully qualified name, to get to it. And they could get to this integer n by using C::N to get to this static data member. Here we have an external constant called k, and we are saying that k is defined someplace else. Remember the extern keyword that we used in C? Well, we still use that here, and we are declaring k. I want to make sure I use the right word there. We are declaring k to exist and be defined someplace else. There can only be one definition, and we talk about that in a couple of videos coming up here. But it can be declared all over the place. And here we have a function declaration, which is a void function. And here we have a new namespace. And this namespace and the class D, which would be ns::D, will have external linkage because of the way it's declared here and defined. And here's an enum that called direction, has up and down, that's 0 and 1. We talked about enums a little bit ago. And that has external linkage because it is declared outside, declared and defined outside anything else in this one translation unit. This is the whole source file translation unit. So that's external linkage. Here's internal linkage. Again, we look at a single source file, a single translation unit. Static functions have internal linkage. So this static f function here is only visible to the other items within this translation unit. Here this static integer q is also declared globally out here, but it is only given internal view or linkage because of it being a static. Here's an anonymous namespace. This is a namespace without any tag, without any identifier. So since it's used this way, we don't have any way of getting a handle on it and referring to it in another translation unit. It doesn't have a name. It puts these items into this namespace, but again, we can't reference it anyplace else, so only the other items that are within this translation unit can get to it. Here's a constant, which is not an extern, so we are declaring this constant right here and defining it, giving it the value 1000, and since it's not declared extern, it's only good here locally. And here's a union. It's an anonymous union. Again, it does not have a name, so we have no way of grabbing hold of it and using it anyplace else but in this one translation unit. And here we have a type def name. The type def is only good in this translation unit. And that's why we do our type defs in header files and then include them in many different, the top of many different translation units, because they don't cross over automatically. You have to include them. And here's no linkage, linkage of names, none. There we have our little integer main, and we have a local class called C, and it is a local class. There's no way to get to it by the other translation units. It needs to be declared outside of main, outside that function, if we want to be able to see it in the other translation units. And there's int j is another local object with no external reference, no way for another translation unit to get a hold of it. Here we have the object. Here's the class. We're making a new one called C, no linkage, no reference outside. Here's another local enum. This is called parity, even and odd. There's the end of main. So we see that this enumerated value is created inside of main, and we can't peek in there from the other translation units, so it has no linkage as well. All right, so that's external linkage, internal linkage, and no linkage of names.